Okay, we're going live, 7th graders, with two-step and multi-step equation solving. This is part 2 of our equations introduction, where we learned how to do one-step equations. We learned some key concepts about what we do to one side of the equation we have to do to the other, as well as how to undo operations. We will now go into into learning mode over here on our sketch pad. Let's get going. So we learned last time a little bit about how to solve equations, and this is the ending slide from that last video, where when we solve equations, we have to remember that whatever we do to one side of the equation, we must do to the other. So here's some examples. We subtracted 9 from both sides. Here's an example where we added 3 to both sides in the course of solving our problems, multiplied both sides by 3. Now, the other thing, the key concept is that to undo operations, we have to subtract. Subtraction undoes addition, and then multiplication undoes division. So when we're doing operations to both sides, we have to know what operation to perform to both sides. Well, the operation that we performed on both sides is the opposite one that we performed on our variable. So in this case, when we added 9 to our x, we undo adding that 9 with subtraction, a subtraction of 9. So that's why we knew how to subtract 9 from both sides. Similarly here, on number 2, we subtracted 3 in our equation, our original equation. So to undo that subtraction of 3, we have to add 3 to both sides, right? Any number minus 3, we add 3 and we get back to that number. And then undoing division with multiplication is what we did here in example number 3. So let me, we're going to just erase all of this work here, and then we're going to come back with a multi-step equation, and we're going to add one more concept to our learning into our hats, if you will. We're going to add the concept of we must, in multi-step equations, we undo operations in reverse order. Well, let's just leave it like that. So let me explain that concept here. So undoing in reverse order. So if I have a 2x plus 4, what did I do to my x here? The first thing I did was I take my x and I multiply it by 2. I multiplied it by 2, and then I added 4. Right? This is the tighter operation. This is what I did first. And then this is what I did. Then this is my first. This is what I did first. And then this is what I did second. Okay? So the key concept is that when I want to undo this operation, I have to do it in reverse order. So the undoing, to undo, what do I do to undo addition? I must subtract 4, because undoing addition means subtraction. And then the second thing I do is then I divide by 2. Okay? So that's important. So let's look at this operation. If I say, well, 2x plus 4 is equal to, say, 14. The way I'm going to solve this algebraically is I'm going to undo things in reverse order to the way that I did them in the first place. So if I said 2x plus 4 is equal to 14, the first thing that I need to do to both sides is undo the last thing that I did. So I need to subtract 4 from both sides. And I get 2x. Remember, the plus 4 and the minus 4 cancel, and that equals 10. And so now I have had, this was a two-step equation, and now I have a one-step equation. So remember, what if I say 2 times x is equal to 10, how do I undo multiplication? Well, I undo multiplication with division. So I'm going to divide both sides by what? Well, by 2. Because I had a 2 times. So now I get x, 2 times x divided by 2 is just x, and that equals 5. Am I done? No, I'm not done because I have to check my answer. So the way I check my answer is I write my original problem down again, 2x plus 4 equals 14, and I put my 5 in for x, so I say does 2 plus 2 times 5, my x, plus 4, does that equal 14? Well, does 10 plus 4 equal 14? Well, does 14 equal 14? And I say yes. So x is indeed correct. It was a two-step equation. I solved it by figuring out what I did first and then what I did second and undoing things in the opposite order. So let's look at another problem. Another problem. After I erase this whole thing, there must be a better way to erase just half of it. If someone knows how to use Sketchpad to erase just half, let me know. I can think maybe of one way, but all right. So let's try a different problem. So this one's going to be a little different. I'm going to say, well, 2 times x plus 4 equals 20. So what did I do first to my x, and then what did I do second over here? So let's write that down. So the first thing I did was I took x and the first thing was I added 4. I didn't multiply my x by 2 first. Just because the 2's first out here doesn't mean I did that first. I took an x and I added 4 because that's what's inside my parentheses. And then the second thing I did is I multiplied by 2. So to undo this, I know that I have to go in reverse order. So to undo, I need to divide by 2. Division undoes multiplication, divide by 2. And then the second thing I need to do is I need to undo my addition of 4, so I need to subtract 4. So let's use that strategy here as we solve this equation. So the first thing I need to do to undo is I need to divide by 2. And that will get rid of my 2. And I'm left with an x plus 4. And then if 20 divided by 2 is equal to 10. I divided both sides by 2, so I've still got a nice equality. Now I had a two-step, and now I have a one-step equation. What undoes addition? Well, subtraction. So we're going to subtract 4, and I get x is equal to 6. Box my answer. Now I'm going to come back and check my answer and say, well, 2 times x plus 4 equals 20. 2 times 6 plus 4 equals 20. 6 plus 4 is 10. 2 times 10 is equal to 20. 20 equals 20. Check. So I have done this correctly. Okay, now this time it's your turn to figure out what to do. And we got to get really solid at doing these. And we have to be able to do these like the back of our hand, always knowing what the right thing to do next is. So let's try 3x plus, now let's do a minus. Minus 9 is equal to 3x, let's see, is equal to 12. So let's figure out, I want you to figure out what the strategy is here. Write down, what did I do first? You know, what did I do first? And then what did I do second? And then we're going to undo it in the opposite order, and then we're going to solve. So I want you to fill this out, and then pause, and then come back. Okay, right. The first thing that we did is we multiplied by 3. Right? We did this first, and then the second thing is we subtract 9. So now I want you to think about what we do to undo these operations. Pause the video and fill out what do you do to undo these operations. Okay, now I'm back. To undo subtracting 9, we have to add 9. Whoops, wrong color. I meant this color. Well, close enough. Add 9. To undo multiplication, we have to divide by 3. So we're going to incorporate this strategy in solving this equation. So let's 3x minus 9 equals 12. So we're going to undo in opposite order. So we're going to add 9. 3x equals 21. And now we're going to divide by 3. Kind of neat how that works out. 3x divided by 3 is just x. 21 divided by 3 is 7. Now we have to check. And we'll say, well, 3 times 7, go back to our original equation, minus 9 equals 12. 3 times 7 is 21 minus 9 equals 12. Well, it's 21 minus 9 does equal 12. So check. So we have done that correctly. All right. So I'm just going to erase this again, and then we're going to do one last problem. And then we're going to leave it there. So this problem is going to be x plus 9 divided by 3 equals 6. Okay. So what's the first thing I did and then the second thing I did, and we're going to undo them in opposite order. So what I want you to do is fill out what we did first, what we did second, and then what undoes that in opposite order. Okay, good. Pause. Okay, the first thing we do is we add 9. That's the first operation. Then we divide by 3. So we undo that by multiplying by 3 and then subtracting 9. So let's use that strategy as we solve this problem. All right, x plus 9 over 3 equals 6. So we're going to multiply. This is our undoing. So we're going to multiply both sides by 3. And when we do that, we cancel these guys and we get x plus 9 equal to 18. Now we're going to subtract 9. And we get x is equal to, well, 18 minus 9 is 9. And now we're going to move into our check step. We'll say, well, does 9 plus 9 over 3 equals 6? Well, 9 plus 9 is 18 over 3. Does that equal 6? Well, 18 over 3 is equal to 6, equals 6. Check. And we have completely satisfied our operation. Now, I'm going to do one more problem, and this one's going to be advanced. We're just going to do an advanced version that's going to be like a 4-step. We're just going to go crazy. And I want to show you that this operation still works. So we're going to say 3 times x plus 2 minus 5, watch this, divided by over, let's see, wait a minute. I got to solve this one in my head real quick. Yeah, we're going to solve this one. Now, what did we do over here on this side? I'm going to let you write in the 3 things that we did. 1, 2, 3, the 4 things that we did, and then we're going to undo them in the opposite order. And you can just follow along if you don't want to solve this one. I just want to show you that it works. 3 to x plus 2. So the first thing we did was we added 2. We added 2. Then we multiplied by 3. Then we subtracted 5. Then we divided by 6. The way that we undo division is multiplication. So we have to multiply by 6. Then we have to, undoing subtraction is adding 5. Multiplying by 3 is dividing by 3. And then adding 2 we undo with subtracting by 2. So we just have to remember to apply things in opposite order, and we will have this solved. So let's write 3 times x plus 2 minus 5 all over 6 equals 5. So we're going to multiply both sides by 6. This 6 cancels with this 6, and so we're left with 3 times x plus 2 minus 5 equals 5 times 6 is 30. We've done that. The next thing we'll do is add 5 to both sides. Add 5. Add 5. So that leaves us with 3 times x plus 2, because these canceled, equals 35. Oh, shoot. This is frustrating, because the reason this is frustrating is because we're going to end up with a fraction. And I don't want to end up with a fraction, so I chose a bad number. I'm going to fix this real quick, and then we're going to just kind of redo it. We're going to turn this one here. Whoops. We're going to turn this one here into a 5. So we should have, to undo this, we're going to do it like this. We're going to divide by 5, and so we're going to call this multiply by 5. Here, we'll just do the whole thing. Watch this. We're just going to do the whole thing again. We should have. Okay, so this here, sorry about that. I don't want to blow off the whole video though. So we're going to go back and we're going to say this was, and you know what? I'm going to even give a better, we're going to say this. Minus 6, and then divided by 8 equals 3. So we added 2, then we multiplied by 3, then we subtracted. And we subtracted 6, and then we divided by 8. So the way that we undo that is okay. is we add 6 and then multiply by 8. And sub 2. Okay, so that should work. So let's copy this again, and let's just get going forward. So we're going to say 3 times x plus 2 minus 6 over 8 equals 3. Now we're going to undo it by multiplying both sides by 8. 24. And if this cancels with this, now we get 3 times x plus 2 minus 6 equals 24. So we did that. Now we're going to add 6 to both sides. And these cancel, so 3 times x plus 2. Now we're going to divide both sides by 3. And we get x plus 2 equals 10. And now we're going to finally subtract 2 from both sides. And so we get x equals 8. And are we done? Well, no, we're not done because we need to do our check step. We'll do our check step right here. And we'll say, well, does 3 times 8 plus 2 minus 6 over 8, does that equal 3? All right. So, well, let's see. 3 times 10 minus 6 over 8 is the same thing as 30 minus 6 over 8. That equals 24 over 8. And so that does equal 3. So our 3 does equal our 3. So our strategy of undoing and figuring out the order in which we did things and then undoing them in the opposite order will always work, even for a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 step equation. So our work here is done. We are jamming. Yes, we have conquered the evil algebra gods, and we are now at one with them, and we are sitting high on. Oh, hello? Someone calling me? Oh, wait, who's doing this? What? All right, we're out of here.